Hey students, so one more topic that I forgot to add in the last normal probability distribution is the reverse. So if we're given the area under the curve, how do we figure out at what value is it that has that relationship with the area under the curve? That'll make more sense in a minute with some examples, so let's get started. So we're going to go back to the reading rates problem for the 6th grade students that we did in the last video lecture. And in this case, instead of asking about values, we're going to actually be given the area first. So in this case, you probably heard things like the 90th percentile before. And how do they figure out what score the 90th percentile is in terms of students that score below or students that score above that percentile? And then perhaps you're trying to figure out the middle group of students to find out what would be unusual for readers, both those that read at a slower rate and those that read at a faster rate. So those are the two problems we're trying to get at by going in the reverse. And again, I'll do a quick Excel lecture at the end of this video on how to do it. So let's get started. If we are interested, for example, in the reading rates and we're trying to figure out the 90th percentile, what we need to know is that the 90th percentile should fall somewhere over where I have it, right? And this is just based on the empirical rule. So the empirical rule lets us know that somewhere between 1 and 2 is the value that we want for the 90th percentile. And if you look, I have the standard normal distribution there for how many standard deviations we would go over so that we could then translate that back to the value for X. Again, Excel could do this really quickly in one step, and I will show you that. But in terms of this, we would get Z equal to 1.28 as our standard deviations that we would go over. And then how do we get it back to the original random variable? Well, if we know we have 1.28 standard deviations to the right, we just take the standard deviation of 24 and multiply it. And then we just have to add that to the middle. So recall that in this case, normally what would happen here is that we would have 125 here in the middle. In fact, let's see right here. We could do this. Remember, 125 is our measure of center. So if we take that value as our measure of center, and then we move it over by the number of standard deviations in terms of the standard deviations that we have, we'll find that about 156 words per minute is the reading speed that is the 90th percentile. So those that read above that perform better than 90% of the other students, and those that perform below that are within the 90th percentile. Now, suppose we want to find the middle 95%. So let me erase this. We can X that out. So here we're trying to figure out the middle 95%. So if you think about it, the middle 95% leaves us with 5% on the outside. So if we have 5% on the outside, then that means that it would be 2.5% for each side. So that's why I have over here to the left the 0.025. Remember, Excel isn't very smart. It can only go up to this value, so it can get this 0.025, but it can't do much else. But because of symmetry, once we have what Z is equal to, and the reason why Z is really useful is because once you figure out one side, you also know the other. So in this case, the lower bound is 78 words per minute because we multiply again the standard deviations times 24, and we take it away from the measure of center. Now, on the other side, it's really easy to get because of symmetry. It's just 1.96 for Z in the positive direction because it's the same distance away, just on the other side. So this is why using the standard normal to get at the percentiles is sometimes easier than using the random variable itself. So here again, we have on the upper end 172, which would round about to 173. So the lower side was 78, And the upper side was 173. Now keep that in mind. I'll do that example when we get to Excel, as well as the previous. All right, so the reason why this is all important is because in inferential statistics, we're going to be talking a lot about Z alpha or Z alpha over 2. So Z alpha is defined as the area to the right of Z alpha. And if it was a negative, then it would be to the left. So take a moment here and think about this. So we're going to look at some common values here. So in the next slide, we're going to look at Z alpha of 0.05 and Z alpha 0.01. We already looked at 0.025 in the last example, and that's another popular one. And then we'll look at how to calculate it for the 50th%. So here, if we have the normal distribution, so Z is the standard normal. So we have the picture of the standard normal here. And if we're looking at 0.05 to the right, based on the definition above, what Z alpha represents, then we have simply 1.645. Again, I will help you do this in Excel. So Z of 0.05 is 1.645 because we can use a formula in Excel to give us that value. But make sure you have this value down. It becomes really useful when we get to inferential statistics. Another important value is for 0.01, and that is Z equals 2.326. That is another critical value that would be very useful to know. And we'll talk about other ones as we get through inferential statistics. But by definition, that's what this means. Now let's extend it to that problem that we were discussing, where we're trying to find the middle 50%. So I have here what Z alpha would be. If the middle is 50%, I also know roughly where it would start, right? The middle between the first standard deviation in total is 68%. So it has to be within that area. So it's a little bit inside the 34% area. And by symmetry and division, if 50% is in the middle, that means 50% is on the outsides. So that means 25% is to the right of Z. So that is the Z alpha at 0.25. And that would equal 0.674. And again, we can do some calculations here. We can find the lower value, which is 108 words per minute. And we can find the upper value, which is 142 words per minute. So now let's switch to Excel and see how this all works. Okay, so here we are in Excel. And we are going to work through the Excel workbook. Let me just make sure closed captioning is enabled. Okay. So if we have here the 90th percentile, that means 90% up to a certain value. We're trying to figure out what that value is. We found in the PowerPoint, it was 1.28. So that's what we're looking for. So how do we get that? We do equal norm. And you see norm.dist, which we discussed a lot already. In this case, we're doing norm.inv. Again, you could shortcut it. If you want to do the standard, you could do S instead. It would be a lot quicker. But if we want to just know one command, let's use inv. The probability for the 90th percentile is 0.90. And the mean and the standard deviation is 0.1. And that completes the entire command in the formula to get the value at which we're interested. So 1.28, as I said in the PowerPoint slide, is the value. And then we did a little bit of work to convert it to reading speed. Well, because Excel is so powerful, we can just use equal norm.inv, and we can use 0.90, which is still the probability. But in this case, we have 125 and 24, which instantly gives us 155.75, which we rounded up to 156 to ensure that the 90th percentile is below. So that's how we get those two values. Now we're working with the 95% in the middle. This one's a little trickier because it's in the middle. It's not values all to the left of some value. So in order to fix that, we know 95% middle means 5% each side, which means 2.5% on each. Let me say this is both sides instead of each, both, and then that means this each side. And the reason that's important is because then we know to the left, we're looking at 0.025. So if we're doing the norm.inv, we're interested in the probability of 0.025, that area to the left, and we still have a mean and standard deviation of 1. And remember, this gives us one side of negative 1.960, and by symmetry, the other side is really easy to do. If you don't have symmetry, it becomes a little trickier. So 2.5% on each side. So if we're trying to get up to a certain value, then the other value, if we don't use symmetry, which is why it makes it trickier, would actually be all the way up to the point at which you're on the other side where there's only 2.5% remaining, which means this is equal to 1 minus 0.025, right? So that's the part that we haven't done. So this then would be norm.inv of 0.975 for the right side and 0.1 for our standard deviation and mean and standard deviation. And as you can see, symmetry would be much quicker. And then you can convert it into the random variable by knowing that this is a standard deviation. You'd multiply it by 24 and then add it to the 125 to recalibrate it, so to speak, to the correct normal distribution. But since we've worked so hard here on these calculations, what we can do is we can do equal norm.inv, and we can do 0.025 for the first one on the left, 125 and 24. That gives us the left side, which, as I had said, was 78 in the previous PowerPoint. And norm.inv for the 0.975, the probability that is up to, but not including that last 2.5%. And again, we have the mean and the standard deviation. And that gives us the 172. Again, we rounded up to 173 to ensure that the 95% is in the middle. If we did 172, we'd miss some of the percent. Actually, then this should be 77 as well. Make sure that we have 95% in the middle. And last but not least, if we have 50% in the middle, that means 25% both sides. 50%, sorry, 50% remaining for both sides, which means 25% for each. So this is just going to be equal to norm.inv of 0.2501. And that gives us the value that we had set in the PowerPoint. And then the other side will be, in this case, 1 minus 0.25, which we've already done. So this gives us norm.inv of 0.7501. And as you can see, symmetry works again. So these should match. And if you wanted to go straight to the random variable itself, you would use the same command, but you would use the mean and standard deviation for that problem. So this is a span of 108 to 142 for the words per minute in this example. So that's how the inverse works. Again, Excel works the same way. It moves all the way up to the percent that you're indicating, starting all the way as far left as you could possibly imagine, working its way across the graph to the right until it gets to a specific value. Hopefully this was helpful, and that is it for normal distribution. I will see you tomorrow when we get to sampling distributions. That uses a lot of these same techniques with one change. The main difference between what we do today and what we do tomorrow is the standard deviation changes, and that is because of the sample size. But we'll get to that tomorrow. For now, relax and enjoy learning this topic. I'll see you in the next video.